And I want to thank again IEEE for giving us the opportunity. Aurelien will join me now for the Q&A session. Aurelien is the head of deployment, global deployment of our underground GNSS technology. We've been deploying this in 8 countries already.
So we have a first question from Alan Newton. The question is, did you have to get waiver from FCC to deploy it, and did it fall into GPS repeater regulatory limitations? So, as Remy said, we only deploy GPS signal underground in totally confined space, which means without outside leakage. And thus, of course, we have to talk with the FCC and regulators basically around the world to be allowed to emit this noise in the underground, but it doesn't bother anywhere outside the world, which is why this is feasible. Okay, second question, how about elevation? Can it simulate that? Yes, it can. Actually, it can simulate all 3 axes, so longitude, latitude, and altitude, and so the elevation too. And we can program whatever elevation we want to, which means if you want us to program, I don't know, minus 1,000 feet elevation, we can. If you want us with a plus 3,000 feet elevation, we can too. It's just basic configuration on the subway simulator. This question is from Neil Glenn. So what accuracy have you been able to achieve in the field? So we have several, as Remy explained, we have several ways of introducing GPS in the underground. We have zone-based location and we have continuous. For the zone-based part, as one subwave only emits 1 point in the entire range of the leaky feeder, or either the leaky feeder or the antenna is connected to, the accuracy for zone-based positioning will be half of the zone, the area that is covered. For 200 feet leaky feeder, it would be 100 feet accuracy. Now this is for the zone-based part. For the continuous parts, it's a bit more complicated. Basic continuous GPS signal emission, which provide this basically the same accuracy as outside GPS in urban environments. Well, it can be, but it can be a bit better depending on the size of the leaky feeder. The shorter the leaky feeder, the better the accuracy gets. That part. And then we can add some software correction algorithm, which improves a lot the accuracy we can achieve on basically all of the devices that have GPS capability. And for example, we are achieving sub-meter accuracy on standard GPS receivers with the continuous subway node.
So you talk about corrections. I just want to make sure that everyone understands what we talk about when we talk about this piece of software. So there are 2 things to take into account. Either you use the system as it is, and you get the same accuracy as outside in urban areas, just like Aurelien said. But then, just like in the outside world, GPS can be improved by software, and there are augmentation services, things like RTK, PPP, that are available for the outside GPS in order to get even better accuracy. Underground, we have our own correction, and this is a piece of software that you can add to a receiver to go way further in terms of accuracy. So the great thing about it is that everyone can use the service with decent accuracy, and for very high accuracy requirements, you can add this technology. And the way this technology works is that it corrects the difference in between the delay of propagation inside a leaky feeder compared to in the air. And also it corrects the geometry, as it's not a straight line anymore with a signal going straight to the satellite to your receiver, but it's like a broken line that can be corrected. So this is how it works. And actually I see here a question, is there an app for phones? So that's what we're talking about here. So first, nobody needs an app for it. It just works how it is. You can use any app using GPS and it will work. But then if you want extreme accuracy, yes, there is an app for that. And that's what we were talking about with correction software.
Exactly. Yes.
So
we have a few other questions now.
Yeah.
So first one I see is, in the case where the railroad doesn't have existing leaky feeders, what do you recommend? Okay, so as Remy said, there are several ways of implementing subway underground. The most common are with leaky feeders and with antennas. The reason why, originally, why we used leaky feeders for emitting GPS signal underground is because they were already placed in most subway underground. And so we just had to connect to these and inject our new signal. It almost doesn't change the infrastructure. Now, when there's no leak feeder, you can still do both, either buy and place leaky feeders in the tunnels, or use antennas. But we've seen that actually when leaky feeders are not already in place, they are much more costly than using antennas at the right amount, at the right place. I'd recommend using antenna.
There are here a bunch of questions on transition between inside and outside. That's it's a fascinating topic.
It is. So first one I see is what is the call start acquisition time? Well, it's a simple answer but because as Remy said, you have the same receivers underground as you would have outside. So I'd say it's basically the same as outside. Outside you have a 1 minute call start acquisition time, then it will be the same underground. All the same.
And I think, well, so that's a good transition. That's and the thing is, we do provide a seamless transition, and when we talk about seamless transition, is on two different parts: in between leaky feeders or in between antennas, and also in between outside and inside. And I wish I could tell you way more about this piece of technology that we implemented there, but this is strictly confidential at the moment. What I can tell you is that that allows your device to not restart in cold start while entering into an underground location.
Yeah. Okay, so next question I see is, how is the accuracy impacted with speed? Well, it's not impacted at all, actually. It's like outside, you use a car or going by foot, accuracy is the same, but it's the same for GPS underpass, you know. Okay. Next one is, does it need to be able to receive GPS above the ground first? No, it does not, actually. As we resimulate all satellites that are supposed to be outside, but we put them inside, the GPS chip of the receivers we are using will think that they are outside, receiving the true satellite. That's how it's powerful, because if you're on the face of the Earth, you'll see true satellites coming from actual satellites. When you're underground, we are resimulating the exact same signal as the one you get outside. So you basically have the same picture and thus the same possibility of hitting position. You don't need to go outside for it.
Also, if you have any other questions, we try to keep this understandable to anyone who's not a GNSS specialist, but have a technical background. But if you want to go into deeper details, we would be really happy to continue this discussion with you. I gave my email and phone number at the very beginning, and you can also find me on LinkedIn and contact me directly there. I'd be happy to help. Same with Aurelien, obviously.
I think I'm seeing last few questions here. CBTC train control. That's a wide question.
So yes, we have planned to support CBTC with European partners. Is your solution compatible with other GNSS systems than GPS, or will it be? So that's something we can imagine for the future. When I said at the very beginning of the presentation that this is derived from the technology that has been developed for the space industry, we do it. We cover most, if not all, the other GNSS technologies for that application. So this is definitely something we know very well how to do. Yeah, the trend would be the first priority would most likely be to provide an even better signal with a multi-frequency first.
Well, the answer is yes, it will be. Okay. I think we've answered all the questions I'm seeing here.
Thank you so much for all your questions. It's really nice to see how much interest this gets, and again, would be really happy to take the conversation further with you guys if you are interested. We are always looking to grow this company, and that comes with having more and more local partnerships with integrators, for instance. So if you are an integrator, if you work with integrator, if you're a subway or a tunnel company or organization, we would be really happy to start the discussion with you, tell you more about it, maybe even show you. That's something we do too, how it works and and you can test it. So yeah, looking forward to hearing back from you, and thank you so much again, Shamara and the IEEE for inviting us. It's a great opportunity, and we really appreciate it.
Yeah, thank you guys for taking the time to give a presentation to us all. Gives us something to learn on the side from our day-to-day. Feel free, I'm speaking for you guys, feel free to reach out to them with any questions or, future opportunities and so forth. Anything else before we close out and give everyone back the rest of their day?
Well, I just want to thank you all for this opportunity, and I hope we can all discuss this further as soon as possible. Thank you for your time.
And I had one more thing. I want to thank you, all our engineering team, who are doing an amazing job building this technology and supporting the deployment all around the world. They're doing an amazing job, and yeah, I want to tell it to everyone today. I know some of them are connected here.
Perfect. All right, with that said, we'll give everybody back their 7 minutes. And I'll be sure to send out the slides, and I'll be in contact with you, Remy, as well. All right, thank you guys for attending. Have a good day.
Thank you.
Thank you.
Bye, everybody.
Thank you. Bye.
Bye, thank you.